here, the secret to this is going to be do a little algebra first. So what I'm going to do is I have this definite integral from 2 to 9, and I'm going to split this up and put it under each term in the numerator. And I'm also going to write it as an x to the 1/2 because that's how we're going to be dealing with, we like things written with exponents so that we can think of antiderivatives. And so now, if I do this, I have the integral from 2 to 9, but I can combine these guys using rules of exponents, and that would be 4x to the 3/2 because this is x to the 4/2 minus the exponent of the bottom there when I combine those, so minus 1/2. So that's x to the 3/2. And then this other one's going to be 4x to the negative 1/2. And I actually could have pulled a 4 out of everything, it looks like, but we'll just keep going now we're this far. So this is going to be, well, let's go ahead and pull that 4 out in front. So we've got the 4, and then we're going to integrate this. So this would have been 1 higher power, which would be the 5/2, and then we need the reciprocal of that power. And then plus this one would have been 1 higher power, so that would have been the 1/2, and we need the reciprocal of that power. And then we need to evaluate this from 2 to 9. So let's go ahead and do that. So this is going to be 4 times 2/5, and then here we need to substitute in 9. So I'm just going to write 9 to the 5/2 plus 2 times 9 to the 1/2, and then minus 2/5 times 2 to the 5/2, and minus 2 times 2 to the 1/2. Because this won't go evenly, this 9 actually would, because this root means square root of 9, which is 3, but this 2, square root of 2, does not go evenly. So what I'm going to do now is just put this in a calculator and get a decimal approximation. And it looks like when I do that, I get 392.435325.